Well, here we are, an opportunity to take all the different formulas and things we've learned throughout the chapter and use them to solve some trig equations. So some of these will require us to use some of the formulas that we've done throughout the chapter in order to solve these equations. So I want to start first with sort of a graphical approach to solve these. And so here's the question. Find all solutions to the sine of x equals 1/3 on the interval from -4 to 4, and we're going to approximate to 3 decimal places. So I want to find out where the sine of x is equal to 1/3. Well, to do that, let's grab a graphing program. So I'm going to pull up Desmos over here. And in order to do this, I'll graph two things. I'll graph y equals sine x and y equals 1/3. I'm going to double check to make sure I'm in radian mode. So over in the corner here, when I click on that little wrench, you see radians is highlighted. That's how I know I'm in radian mode. So just double check that before you get too far. So the part of the screen you're seeing, the sine is the red function, the 1/3 is the purple function. I want to find out where they intersect. Well, it said from -4 to 4. So it looks like they intersect right there. Right? You notice the y value is 1/3. The x value is -3.481. But the red and the blue line intersect again here. So if I click on it, it'll put the intersection points in there for me, and then I just keep clicking. Right? Click again. Over here, we're past 4. So between -4 and 4, there's 3 places where it happens. At -3.481, at 0.34, at 2.802. And if I wanted to go one more, I can go over here and get 6.623. So it looks like the two curves are going to intersect a lot. They're going to keep going and going and going and intersecting repeatedly. So perhaps there's a way that I can write my answer that encompasses all the possible values. Let's take a look at that -3.481. Suppose I took -3.481 and added 2 pi, because I remember that every 2 pi, the function repeats. What do I end up with? Look, you can see it in the box down here. I end up with 2.802. Where is that? Is that over here? It is, right? So here's -3.481. If I add 2 pi to it, I get this answer. If I add another 2 pi, I get the one that's just outside the range of your viewing screen. What about the other one? The other one was 0.34. So here, I'm going to take 0.34 and add 2 pi. I get 6.623, and that's the one right over there. So if I can find 2 of the points, then I just keep adding 2 pi, and every cycle of 2 pi, that thing repeats. So how am I going to write my answer? Well, I can write it like this. I can say that my answer is -3.481 plus 2 pi n. So if I just want it on the interval from -4 to 4, then my answers are x equals -3.481, x equals 0.34, and x equals 2.802. But if I want what we call general solutions, or another way the question might be asked is find all possible values of x for which the intersection happens, then I would do this. I would do the -3.481 plus 2 pi n, and then I would pick the other one, 0.34 plus 2 pi n, where n is some integer. So in other words, 0.34 plus 2 pi, 0.34 plus 4 pi, 0.34 plus -2 pi, -4 pi, and so forth. All right, so that's how we look at it graphically. How do we look at it algebraically? So this says find and describe all real numbers x, such that cosine of x is 1/2 and so forth. So 1 and 2, I want exact answers. 3 and 4, I want approximate answers. So the first one is pretty easy. All we have to do is figure out where on the unit circle the cosine of x is 1/2. And so in the first quadrant, it happens at pi over 3. Cosine is also positive in the fourth quadrant. So in the fourth quadrant, it happens at 5 pi over 3. So I can write general solutions by saying x equals pi over 3, and then remember cosine repeats every 2 pi, so plus 2 pi n, 5 pi over 3 plus 2 pi n. All right, the second one says the secant of x is negative 2. Well, I can flip over secant and get cosine, so if I take the reciprocal of secant, I get cosine. Take the reciprocal of negative 2, I get negative half. So now I'm looking for the places where the cosine is negative. Must be second quadrant, third quadrant. So we're looking at 2 pi over 3. That's where cosine is negative half in the second quadrant. And we're looking at 4 pi over 3. That's where it's negative in the third quadrant. If I want general solutions, then again, I remember that secant is like cosine. It repeats every 2 pi. So it happens at 2 pi over 3 plus 2 pi n. And then 4 pi over 3 plus 2 pi n. So every 2 pi, I get additional solutions. Now, look at the third one. The third one says the tan of x equals 0.573. For this one, I'm going to need a calculator. So I'm going to have to grab a calculator and say then x equals the inverse tan of 0.573. I would like to answer in radians. So I grab my calculator, and tangent is positive in the first and the third quadrants. So let me find a first quadrant solution and then add pi. So on my calculator, it's second and tan produces an inverse tan, 0.573. And I have to make sure I'm in radians in order to do this. I get 0.520. So one solution is x equals 0.520. But then remember that tangent repeats every pi. So all I have to do is say plus pi n, and I'm good. All right, this one says the sine of x equals a quarter. So x must be the inverse sine of a quarter. So I can grab my calculator, again, in radian mode. Second and sine gives me inverse sine of a quarter. And my calculator gives me 0.253. But there must be a second solution to that somewhere. So the sine is positive in the first quadrant. It's also positive in the second quadrant. So how does that work? It's positive here in the first quadrant. It's positive here also in the second quadrant. So whatever that angle is over here, I should be able to do 180, or in this case, pi minus that angle to get the other one. So if x is 0.253, x is also pi minus 0.253. And then I just grab my calculator. Pi minus 0.253 gives me 2.889. And again, I have to remember that sine is positive first and second quadrant, so whatever I have first quadrant, pi minus that angle gives me the second quadrant. And then for each of these, we just add a 2 pi n. So the general solutions, 0.253 plus 2 pi n, 2.889 plus 2 pi n. Those are my general solutions. And when you're first starting them, you could always check by graphing, make sure they're correct. All right, this one says solve and give exact values in two different ways. One on the interval from 0 to 2 pi, and one over the set of all real numbers. So how do I do this? 4 sine squared x equals 1. So start by adding a 1 to both sides. And I get 4 sine squared x equals 1. Divide both sides by 4. And I get sine squared x equals a quarter. Square root of both sides. If I take the square root here, I've got to put a plus minus. So I get plus minus, the square root of 1 is 1, square root of 4 is 2. So I get plus minus a half. So now I need to find all the places where the sign is either a half or negative half. So in the first quadrant, it happens at pi over 6. second quadrant at 5 pi over 6. Those are the two places where the sign is positive half. Now go third and fourth quadrant to see where it's negative half. So if it's 5 pi over 6, it's also going to be 7 pi over 6, and then 11 pi over 6. So how can I shorten up my answer? Because I don't want to do a plus 2 pi n for each one of these. So this is the answer to part A on the interval from 0 to 2 pi. Over the set of all real numbers, you notice that if I have a pi over 6 and I add pi, I get 7 pi over 6. Add pi to that, I get 13 pi over 6. So I can actually add pi n and then try my 5 pi over 6. If I add a pi to that, I get 11 pi over 6, and so forth. So I can actually take all four of those answers, cut them down to just 2, because pi over 6 repeats at 7 pi over 6 if I add pi. 5 pi over 6 repeats at 11 pi over 6 if I add pi. So over the set of all real numbers, those are my solutions for x. All right, let's take a look at these. Cosine theta minus cosine sine equals 0, solved just on the interval from 0 to 2 pi. Well, I see a common factor. I'll jump on that first. So I'll pull out a cosine theta. Cosine divided by cosine is 1. In the second piece, if I get rid of a cosine, I get a sine. So you notice now these are two things that multiply to become 0, which means that one, the other, or both of them are 0. So either the cosine of theta is 0, or 1 minus sine theta is equal to 0. Where is the cosine equal to 0? The cosine is equal to 0, top of the unit circle, bottom of the unit circle. Over here, add a sine theta to both sides, and I get 1 equals the sine of theta. So where is the sine of theta equal 1? That happens at pi over 2. Which is redundant, because I already have a pi over 2 on the other side. So here's my answers. That second one over there is a cosine equals 1 minus 2 sine squared. All right. Well, in order to solve this one, I'd like everything in terms of the same trig function. I know identities to turn sine squares into cosine squares, but I can't turn cosines into sines all that easily. So we've got to make a decision as to which way to go, and I say we take the sine squares and turn them into cosine squares. So I know that cosine squared theta plus sine squared theta equals 1. So if I subtract a cosine squared from both sides, sine squared equals 1 minus cosine squared. And that's what I'm going to replace this sine squared over here with a 1 minus cosine squared. So I get cosine theta equals 1 minus 2 times 1 minus cosine squared theta. All right, so this gives me cosine theta equals 1 minus 2 plus 2 cosine squared theta. Move the cosine over to the other side, and I get 2 cosine squared theta. Subtract the cosine from both sides, so I get minus cosine theta. And then 1 minus 2 is just negative 1. Now, we can factor this. I hope. This will give me a 2 cosine theta here and a cosine theta there. Those are the only two things that will multiply to be a 2 cosine squared theta. Factors of 1. 1 and 1. One of them has to be positive, one has to be negative. Well, if I want the inside term to be negative, then whatever multiplies by that 2 cosine theta better be negative. And so I'll put the negative here, because that 1 is actually what interacts with the 2 cosine theta. Then I'll put the plus there. Please double check your factoring. 2 cosine squared minus 2 plus 1 is negative 1. 1 times negative 1 is negative 1. All right, so now I got two factors that multiply to be 0. Set each of them equal to 0. So 2 cosine theta plus 1 equals 0, or cosine theta minus 1 equals 0. So I have 2 cosine theta equals negative 1. Divide both sides by 2. Cosine is negative half. Here, if I move 1 over to the other side, I get cosine is 1. So I need places where either the cosine is negative 1/2 or the cosine is 1. I'll give myself a little more room here. So over here, the cosine is negative 1/2. Those are x's, so it has to be second quadrant, third quadrant. So 2 pi over 3, 4 pi over 3. The cosine is 1 at 0 and 2 pi, but the question said don't include the 2 pi, right? So I'm only going to include the 0. So theta equals 0, 2 pi over 3, 4 pi over 3. If the question had put a bracket around that 2 pi, then I would have included the 2 pi in my solution as well. All right, these are fun. Let's try some more. This one says solve on the interval from 0 to 2 pi, including the 2 pi. So the first one, we've got a sine squared and a minus 4 cosine squared. We can go either way with this. We can turn the sine squares into cosines, the cosine squares into sines. I don't know. Let's turn the sine squared into a cosine. So instead of sine squared, let's think of that as 1 minus cosine squared. And we'll just bring down the minus 4 cosine squared. So I get 1 minus 5 cosine squared equals 0. All right, move the 5 cosine squared to the other side, and I get 1 equals 5 cosine squared x. Notice there's no middle term in here, which is why I moved them over to the other side. If I divide both sides by 5, I get 1/5 equals cosine squared x. And so now I need to take the square root of both sides. And I get 1 over the square root of 5 with the plus minus equals the cosine of x. Now that's not something that I know off the top of my head. It's not a nice unit circle value. So I need to jump on my calculator and find out what the inverse cosine of 1 over root 5 is. So x is going to be the inverse cosine of 1 over root 5. So when I punch that in my calculator gives me one answer. It gives me 1.107 in radians. Now, think about cosine. Where's cosine positive? Second quadrant, fourth quadrant. So if that's second quadrant, where is it on the fourth quadrant? It's got to be down here. So in other words, it's 2 pi minus theta. Right? If this is theta, then the other value down in the fourth quadrant is all the way around the unit circle, except for theta. So the other possible value is 2 pi minus 1.107, which gives me 5.176. So on the interval from 0 to 2 pi, here are my two answers. That's one of them. That's the other one. All right, let's do one more, and then we'll split this into a second video for the second part of this. This one over here says sine x cosine x equals square root of 3 over 4. Well, I know a formula that says 2 sine x cosine x equals the sine of 2x, but I don't have a 2 sine x cosine x, I have just a sine x cosine x. Well, that can be fixed pretty quickly with a red marker, and we multiply both sides by 2. And so now on this side, I've got a 2 sine x cosine x. Well, 2 sine x cosine x is the sine of 2x. On the other side, I get a square root of 3 over 2. Now, somewhere on the unit circle, the sine is equal to square root of 3 over 2. And that happens in the first quadrant at pi over 3, and it happens in the second quadrant at 2 pi over 3. But just look at what it is we're solving for. We're not solving for x anymore. This is saying the sine of 2 times some angle equals that. So 2x is equal to pi over 3, or 2x is equal to 2 pi over 3. Divide through by 2. So half of pi over 3 is pi over 6. Half of 2 pi over 3 is 1 pi over 3. And it looks like I'm done, but oddly enough, I'm not done. There's a quirk in this problem, in that if I answer as pi over 6 and pi over 3, I've taken care of the first quadrant. But yet there's another place where multiplying sine times cosine produces a positive. Where is that? It's in the third quadrant where everything is negative. So in the quadrant 3, I multiply a negative times a negative, and I get a positive. So if pi over 6 works, then pi over 6 plus pi, in other words, 7 pi over 6, also works. And if pi over 3 works, then pi over 3 plus pi, which is 4 pi over 3, also works. Which means that this equation has 4 solutions: pi over 6, pi over 3, 7 pi over 6, and 4 pi over 3. So the 2 solutions in the bottom were found by taking the 2 solutions in the top and adding essentially 2 pi over 2, which is pi. Let's graph this and see how that works. All right, so there it is. I set it up. I did the work and paused the video. I didn't think you wanted me to graph it in real time. So I graphed it from 0 to 2 pi, and I graphed both sine x, cosine x, right? If I come over here, you can see I graphed sine x, cosine x, and I graphed square root of 3 over 4. So look to see the places where it intersects. It intersects here at pi over 6. It intersects here at pi over 3, but then it comes around a second time, and it intersects at 7 pi over 6, and again at 4 pi over 3. So this graph actually has 4 intersection points, once around the unit circle once, but because there was that 2x involved, we got to go around the unit circle a second time. All right, we'll do a second video with the rest of the solving equations.